Alright, Chem students, today we're going to start our atomic structure and nuclear chemistry unit. You need your notes packet, your practice packet, and something to write with. Let's get started. Now, the atom is the smallest particle of an element that retains the properties of that element. That's important to remember because we're going to go in detail about what makes an atom and how that idea came forth. Now, the first person to come up with the idea for an atomic model was a guy named Democritus. Now, Democritus was an ancient Greek philosopher, and his theory included the following ideas. First, matter is made of tiny, solid, indivisible particles, which he called atoms, coming from the word atomos, the Greek word for indivisible. Different kinds of atoms have different sizes and shapes, and different properties of matter are due to the differences in size, shape, and movement of those atoms. Now, even though Democritus was right, his ideas were widely rejected by his peers, most notably Aristotle, who was alive at the same time. Now, Aristotle was a very influential Greek philosopher who had a different view of matter. He said the four elements were earth, air, fire, and water. Now, because of that time in history, these are just some philosophers sitting around drinking wine. None of them had experiments to actually test these ideas. So Aristotle's ideas won out. Democritus's ideas were revived when John Dalton came along in the 19th century. Now, John Dalton was our first guy who actually came up with a good idea and theory about what an atom was. And he created three basic laws. The first one is the law of conservation of mass. He said that matter cannot be created or destroyed during a chemical reaction. He also came up with the law of definite proportions, meaning a chemical compound always contains the same proportions of elements by mass. And the last one, the law of multiple proportions. It basically said that elements combine with each other in ratios of small whole numbers. Now, John Dalton formulated this first modern atomic theory around 1800, and his theory was summarized by 5 main points. First one, all matter is composed of extremely small particles called atoms. Second, all atoms of one element are identical. Third, atoms of a given element are different from those of any other element. Fourth, atoms of one element combine with atoms of another element to form compounds. And fifth, atoms are indivisible. In addition, they cannot be created or destroyed, just rearranged. Now, Dalton's theory was of critical importance because he was actually able to support these ideas through experimentation. And his work revolutionized scientists' concept of matter in its smallest building block, the atom. What he didn't know is point 2 and point 5 weren't quite correct. In point number 2, that's not totally true. There are isotopes of a given element that are not totally identical. They differ in the number of neutrons. Scientists couldn't know that at the time, but there were things called isotopes. And in point 5, atoms are not indivisible. We know now that we can make even smaller particles called protons, neutrons, and electrons. And we can break them down like in nuclear explosions and nuclear reactors and such. Atoms are not indivisible. We can divide them. Now, the next guy to come along and add to our atomic model was J.J. Thomson. And I'm going to give him a baseball-style nickname. I'm going to call him Plum Pudding Thomson. Now, Plum Pudding Thomson discovered the electron in 1887, and he determined that it had a negative charge. And he did this with experimentation using cathode ray tubes. Basically, cathode ray tubes used to be what were in televisions and computer monitors, and some of you may remember those, some of you may not. But you can thank J.J. Plum Pudding Thomson for discovering the electron. He called his theory the plum pudding model because he said there wasn't just an atom, but there was this big clump of positive material that had these little negative electrons scattered throughout, kind of like plums in plum pudding. Now, our next scientist, Ernest Goldfoil Rutherford, discovered the nucleus in his famous gold foil experiment in 1909. Now, Goldfoil Rutherford would shoot alpha particles from polonium at a sheet of gold foil. Now, he expected the alpha particles to pass straight through the gold, but it didn't happen that way. A lot of them went straight through, but sometimes they would bounce off as if they hit something relatively dense and large. And he named this thing the nucleus. But because so many of the alpha particles did pass straight through, he also concluded that in addition to the nucleus, there was a lot of empty space, as you can see on the diagram to the side here. He would later discover the proton, and then working with his colleague, James Chadwick, he also discovered the neutron as well. Our next scientist is Niels Big Bang Theory Bohr. So I call him Big Bang Bohr because he came up with the idea that electrons travel around the nucleus like planets. Like our nucleus is the sun, and the little electrons are like planets following orbits. This, unfortunately, is not the case. It was later proven wrong. Now, this theory was later proven wrong. So Big Bang Bohr was on the right track, but not quite there. Now, all of these scientists led to the final model called the quantum mechanical model. This is our modern atomic theory. It is a mathematical model, and it was developed in the 1920s by the work of many scientists, including de Broglie, Schrödinger, Pauli, and Heisenberg. No, not that Heisenberg. This is the original one. We now know that electrons exist in regions of space around the nucleus, which are called orbitals. The paths of the electrons within those orbitals are random and cannot be predicted. We can only talk about the probability of an electron being in a certain region. So electrons have a high probability of being located near the nucleus. And we have here on the side a diagram of what the quantum mechanical model looks like. So to review, Dalton came up with the idea that there was an atom. Plum Pudding Thomson came along and said, okay, the atom is mostly positive material, but there's these little electrons scattered throughout. Goldfoil Rutherford came and said, wait a minute, there's a nucleus in the middle of that atom, and it's got the electrons falling around outside somewhere. Big Bang Bohr added to that and said, okay, there's a nucleus, and the electrons travel around the nucleus in orbits like planets, which is not right, that was proven wrong. And then finally, our quantum mechanical model. That's the mathematical model that we still use today. So take a minute, make sure you get all of these diagrams written down. I hope you like the nicknames. They help me memorize these guys. And make sure to do the work in your practice packets. We'll see you for the next video.